Hi, welcome to solveandgo.com. In this video, I'm going to give a second example of a related rates problem. This one has to do with geometry. Let me show you the problem. Okay, so the height of a triangle is increasing at a rate of 1 centimeter per minute, while the area of the triangle is increasing at a rate of 2 centimeters per second, 2 centimeters squared per minute. At what rate is the base of the triangle changing when the altitude is 10 centimeters and the area is 100 centimeters squared? Okay, so let's begin by drawing a picture. Okay, again, this is always the first step with a related rates problem. So we have a triangle. We have a height here. We'll call the height h of t. So this is the height at time t. And then, of course, we have the base. B of t is the base at time t. Okay, so this is a 90-degree angle. And we know the area, A of t, is 1/2 the base times the height. Okay, what we also know is that the height is increasing at 1 centimeter per minute. So that's the derivative of the height function is 1 centimeter per minute. And the area is increasing at a rate of 2 centimeters squared per minute. So A prime of t is 2 centimeters squared per minute. Okay, so that's the general setup. So with the area function defined like this, we need to, so we're asked for the rate of change of the base of the triangle. So the first thing to do is to take the derivative of the area. So let me erase what we have here. I'm going to keep the rates down at the bottom for reference. Okay, so again, we have A of t is 1/2 B of t times h of t. Okay, take the derivative, and we get 1/2. So let's use the product rule. B prime at t times h of t plus B of t times h prime of t. Okay, so we need we're looking for B prime of t. Okay, at the time t equals, we don't know the time actually. What are we given? Okay, so we need B of t when A of t is 100 and h of t is 10. So let's see. Let's look at our formula up here, the derivative formula. I'm going to highlight it. Okay, which quantities do we know up here? Well, we know A prime of t is 2 centimeters squared per second. We know h prime of t is 1. We know h of t should be 10. Now, what's B of t when A is 100 and h is 10? Well, we know the area is 100, and this should be 1/2 of the base times the height, which we know is 10, which is 5t. 5 times B of t, rather. Okay? So this is telling us that when the height is 10 and the area is 100, B of t will be 100 divided by 5, which is 20. Okay, so we just solved for the base when the area is 100 and the height is 10. Okay, that was the missing piece we needed to fill into this formula up here. Okay, so let me erase this. We're going to plug everything in. What we get, so a prime of t is 2. We take 1/2 of b prime of t is what we're looking for, times h of t. H of t we're told is 10, plus b of t, which we just found was 20, times h prime of t, which is 1. Okay, so we get, in the end, 5 b prime of t plus 10 equals 2. Solving for b prime of t, what we get is 5 b prime of t is -8. And so finally, what this tells us is that b prime of t is -8 over 5. Okay, and that's our answer. So we're going to erase this. Okay, so the negative is accounting for the fact that, well, it's telling us that the base is decreasing in length, okay, as the height is increasing. Let me just make a comment here. So that's the end of the problem. I just want to make a comment on the formula for the derivative of the area. In physics, you often check the units on both sides of a formula to make sure things sort of check out. So let's see the units in each of these quantities here. A prime of t is the rate that the area, so that's centimeters squared, is changing versus time. So it's centimeters squared per minute. Here, well, b prime of t has units. So the change in the base in centimeters per minute. And then h of t has units centimeters. Okay, and here we have centimeters for the base, and then the height's changing with units centimeters per minute. Okay, so each of these, we have centimeters times centimeters over minute, centimeters squared per minute here, and we're adding to that here again, centimeters times centimeters is centimeters squared per minute. Okay, and we add those together to get units of centimeters squared per minute. Okay, you can only add identical units. Okay, so both sides of the formula have the correct units, which is, it doesn't show we have the right formula, but it sort of reassures us. Okay, that's it.